Okay, what I've got here is a 2019 Nissan Altima. It is a 2.5 liter engine. This car had a lean code in it, P0171. Very intermittent problem. The car would surge, it would hunt, it couldn't find its idle, and sometimes it would even stall out. I've been fighting with this car for a while, duplicating the issue with the test equipment in the right spot was a challenge just because of the intermittency of the problem. So finally, when I got this thing to act up, I did have a scan tool on it, but I had to consult the factory scan tool on it, and its recording capabilities suck, and its graphing and pretty much its data gathering is terrible. I do have a pico capture of it acting up. I can't show you the scan data because I thought I hit the record button, but I didn't. So I do have a pico capture. So when I saw the scan data, the car went extremely lean. Up until the point it acted up, it ran fine. I mean, perfect. Had plenty of power. It just, it would lean out, completely lean out, instantly. It's almost like the fuel injector's cut off. One thing I have seen in the past, and I've seen it on some of our GDI. This car is GDI. It is direct injected. You probably knew that from the title. I have seen ECU problems with these. All of our drivers that carry the high current and the capacitors that supply the high voltage are in the ECU. I have seen ECU failures on some of our GDI cars. And when you shut these injectors off, they immediately go lean. And if they pick back up, then the car will surge. So that's what I'm thinking is wrong with this car. So I put an amp clamp. You can see here, our computer supplies the power. The capacitors charge. They shoot about 65 or 70 volts down this line. They're kind of batch fired, or if you think about a waste spark system, which I'm going to talk about this more at the end of the video. So it shoots power down the companions. This is number 2 and number 3. And this is number 1 and number 4, and depending on what injector this thing needs to fire, the computer decides to ground whichever one's in the firing order. But it always charges both, and it only grounds one depending on which one it needs. So my first setup is I've got an amp clamp around this, and I thought I had an amp clamp around this, but it actually was around that. It doesn't really matter. I found out what I needed to find out, although I put the clamp around the wrong wire. And I also am back probing the mass airflow sensor. I'm looking for a couple of things with my first capture. One, I'm looking for a failure for a driver that can't carry current within this ECU, or I'm looking for an input that can change the fuel air mix instantly. And I decided to pick on the mass airflow sensor because I could tell it'd been tinkered with. It had been changed. The screws were a little messed up. So I just went there, a little investigative. So my first capture is an amp clamp, and the mass airflow sensor. So let me show you that and go over what I found. This is just a small cut of the actual capture. This is when it started acting up. This amp clamp, the red trace was actually around 1 down here. It was firing twice. So you'll see that this one fires 2 times, this one fires once. Like I said, it's irrelevant. I did learn what I needed to learn from this capture. First, if you look where I put this cursor at, you kind of see the waviness. This engine's idling bad. It's surging. It's acting up right within this capture. And although it didn't tell me what's wrong with the car, it told me what I suspected, which I was thinking I had some driver issues. It told me that that was not my problem. So there again, I'm testing good parts, but I'm eliminating a theory that I have. So, and this green trace is a mass airflow. It's digital. I wanted to make sure there was no fallouts when this car was acting up. You can see it was kind of hunting in here, and then it actually stalled. And then I stopped the capture. Eventually this flatlined to 0. So let's look at in here where it's somewhat behaving. Like I said, this is a current ramp of direct injection. So I'm just going to pull a cursor out. I don't know exactly where the fuel injector opens, but I'm just going to put a measurement there, and I'm going to put a measurement there. And as long as I keep it consistent, measuring spots, it should tell me what I need to know. 1.2 milliseconds. So I'm going to lock these rulers. See the little lock right there? And you can see the mass airflow looks good. There's no fallouts. There's no issues right in here. So rulers are locked. I'm going to zoom back out. So let's move down here. Let's just pick a spot right here. Seems to be doing good. All right. This thing is lengthened the pulse width. Multi-port engines or port fuel injectors, they depend heavily on the length of the pulse width. Fuel pressure is usually right at 51. Like a 2018 with this same motor would be 51 psi, and as the computer needs to richen or lean, it changes the pulse width. GDI engines, the pulse widths are generally really short. The fuel pressure is changed. This thing idles at about 560 pounds of pressure. If it needs to richen or lean, the computer really doesn't tailor the pulse width much. It ramps the fuel pressure up or lowers the fuel pressure. So to see this sort of a change here kind of sticks out. But what I am seeing, or what I'm not seeing, is I'm not seeing any driver failure. This thing, the capacitor is able to charge this dude up. I'm pulling 8.1 amps. That's telling me I've got plenty of voltage. And then once the ECU kind of takes over and is controlling, you know, the capacitor charges, pops this dude open, and then source voltage keeps it open. So 3.2 amps. So I'm not questioning any of the driver. I'm not right now, after I'm seeing this, I'm a little bit disappointed that this is not the problem. But I'm not seeing any ECU issues. So let's get out here a little closer. Let's go right in here. Let's just pull our cursors out. Now look how wide. Actually, we move it to there. This thing is really commanding this injector on. So I've learned 2 things. One, I don't think my computer has a fault with powers or grounds. I think the drivers are fully capable of doing their job. 2, I don't have any fallout with this mass airflow. This pulse width has dramatically increased. The mass airflow is ticking right along. And this engine, I know you guys can't hear it or weren't there, but I can tell you this thing was hunting around. It was idling up and down and surging and doing all kinds. Now look at that. Let's look at this one first. Now look how wide that injection pulse is. That is crazy. But what I'm feeling like is these injectors they're doing exactly what the computer wants it to do. So my thought process, and look how narrow this one is. So my thought process is, what kind of crazy input, other than the mass airflow? You can see the mass airflow is ticking right along. The mass airflow is good. And then the very next pulse is still a little wide. So here's my thought process. What input on this motor would drastically make this fuel injection system act this crazy? And it's not the mass airflow. So I'm thinking, well, GDI systems are heavily dependent on fuel pressure. That means that they are heavily dependent on the accurate reporting of the fuel rail pressure sensor. So after a lot of thought, I decided to go ahead and put my eggs in one basket, and I'm going to hope I can get this car to act up again, because this thing is extremely intermittent. And I'm going to put all my eggs in one basket, and I'm going to attack the fuel rail pressure sensor and hope to goodness I can find something, because I can't think of another input that would make such drastic changes within one cycle. The mass airflow is ruled out. Even if the low side pressure were disconnected, I don't think, because these engines will idle if you pull the low side fuel pump, they'll idle for 30 or 40 seconds before they'll start really acting silly. This engine acts silly instantly. It just feels like in its electrical problem. So I decided to go all in, rehook up at the fuel sensor, and I'm going to show you where my hookups were. So here's the fuel rail pressure sensor here. So I am going to be back probed at 44, and all these checks are at the computer. And then I'm going to be back probed at 45, which is a ground. There's a lot of little dudes on that ground circuit. And then I'm going to be back probed at 43. So the computer is supplying the 5-volt reference and supplying the ground and of course the signal wire. So I'm going to be hooked up there, and I'm going to leave an amp clamp on one of the injectors, and here would be the capture of that. And I caught it. It was acting up. So my green here is an amp clamp on number 2 fuel injector. The red is the power supply to the fuel rail sensor, which you can see it maintained 5 volts through the incident. The yellow trace or gold trace here, that is my signal. That is the return. You can see it went open. And then the blue trace is the ground. So the problem I'm having is I am back probed at the computer. So the problem is pin fit or the computer itself. I am losing ground, which is throwing my fuel rail sensor completely nutso, causing the car to surge. So what's happening is it's idling fairly good in here. So let's check just to kind of prove a point where it's idling good. Let's just drag a couple of cursors out, and we'll just put them right there, and we'll put them right there. 1.165, and we're going to lock them again. So this dude falls out. Well, I can tell you this thing's idling about 550, 560 PSI. It falls out. The computer spazzes out. The rail still has 570 some pounds of pressure in it. And then when it comes back online, the computer was shutting some of the injectors off, so we lost some pressure in here. So low voltage is low pressure. So let's go right here. So you can see it really widened. The computer really commanded a lot of pulse width. The problem is the rail had plenty of pressure in it. So when that computer opened this dude, thinking it was low pressure, well, this thing still had 570, so it really drowned the cylinder. The computer thinks it has very low pressure. In fact, it has plenty of pressure, so it opens it wide. It drowns the cylinder. The feedback system is screaming. So now, the very next pulse, right here, let's pull our lock cursors over. It says, holy shit, way too much fuel. Let's cut it way back. So that's where the surging comes in. The computer is changing the pulse width, thinking it's low pressure, and then it has plenty of pressure, so it drowns the cylinders. So then the next cycle or two, it leans it, so the idle is going up and down, up and down, up and down, and finally it leans it so much in some spots it cuts off. I was monitoring the throttle position sensor, and I can tell you the throttle blade wasn't moving. This thing was trying to fix itself by fuel. It's kind of interesting how that works. So right in here, it starts widening. The fuel pressure drops. It panics, ramps fuel pressure up, shortens everything, and if this capture would have kept on, it would have been really wavy until finally it settled out until this thing went open again. So once I saw this, I have lost a ground. So I've got an issue with the computer itself or the pin fit at the ECU, because all this testing is at the computer. So let me show you a little video. If I can get this to come up. Let's see. Exit out of a bunch of screens here. So let's watch this little video here of me getting it to act up. So I'm wiggling this harness. This is at the computer. And you can see the scan data. See the fuel rails dropping down, picking up, dropping down. It's really spazzing this thing out. So, do I have a solder joint messed up inside the computer, or do I have pin fit? So let's find out. Check out this video. I have depinned the ground for the fuel rail sensor. And I'm testing it. And you can see this dude has zero tension on it. What I've done is I've put a new pin in the computer. I haven't soldered the wire in yet. So I'm just going to show you how tight the new pin is. Right there. It's pretty snug. So that kind of fixed the car. But what I found was interesting is this thing only had one trouble code in it, and that was P0171. So let me exit out of that. Let's show you some, let's go back to the wiring diagram. Where's it at? Right there. So pin 45, that was the pin that I just showed you that was loose. Pin 45 is the ground for fuel rail pressure sensor, engine oil pressure sensor, battery current sensor, and refrigerant pressure sensor. This was kind of neat. So I decided to go ahead and pull the scan data up while I was wiggling. And there's engine oil pressure, AC, battery, and fuel. Every one of these things was opening. So that ground was creating havoc in a lot of other systems, but I never seen a light. Not sure if the AC, if it acted up long enough where the AC would go hot. It doesn't look like it. Some of the charging issues with the motor surging and the voltage changing could be because of this. And of course, our fuel rail sensor was ultimately our problem. So I thought that was kind of neat. I'm going to show you this last video of me. It's kind of fixed. And then after this video here, it shows it fixed. And then I'm going to put up one more capture if you want to stay tuned, and I will show you what I was explaining about these things being batch fired. So here's a video here of it being fixed. So I've already put it together, soldered everything. I'm putting the wiggle job on that. There's my fuel sensor, fuel PSI. You see everything's holding pretty good. Confident this one's fixed. But interesting job, very intermittent. I thought I was going to have a driver problem in the ECU. I was wrong. That's part of it, man. I've tested a billion good parts. It seemed like very rarely do you test the bad part first. But I wasn't going to just start chunking parts on this thing. The old loose pin fit, it'll eat your lunch. So what I was talking about, these things being batch fired. Actually, let's go back to the diagram one more time. So in the next capture, what I've done, pretty much that case study's over. This is kind of the bonus area. What I've done is I have back probed voltage on 2. Now I'm here. No, I'm sorry, I'm here. I'm at 3. I back probed the ground side, so I'm going to call this the high side, the low side, and I'm looking at current. And you're going to see that this thing pulses power and it goes to both. But current only flows depending on which injector the computer wants to ground. And consequently, these are companion cylinders. 1 and 4 are on the same power leg, they're companion. And 2 and 3 are on the same power leg, they're companion. I just think it's neat the way the GDI system works. So here is the capture right there. Let's zoom out. So there you go. Here's my powers, here's my current, and here's my low side. So I have power. The computer has grounded it. Let's look at that zoomed in. So it pulses it, it grounds it, I have current. The very next, it pulses it, no ground. These are mirror image. This is open source voltage. These are mirror images of each other. I mean, there's no ground, so therefore no current. And then of course, whoa, better zoomed in a little tight. So I put some cursors out here just to kind of show. 4-cylinder engine fires every 180 degrees. So there's our fire. 360. This would be its companion on the exhaust stroke, kind of like a waste spark ignition. Obviously, it didn't ground it because it does not want to spray fuel on number 3 when it's on the exhaust stroke. I've seen these drivers fail. The capacitors, they may leak and they're not able to supply. Let's look at the voltage. I do have an attenuator on this. I have a 4423 scope. It can handle up to 100 volts. I just use an attenuator. No need to waste a channel on some stray voltage. So that dude tops out about 64, 63, 64 volts. It gets the injector moving, and then it only takes about 13, source voltage to keep the injector open, and it's pulsing it, and it's grounded the whole time. So it's power side controlled, I guess we could say it that way. I don't know exactly where it starts spraying. There really is no pintle hump that I know of, or at least not on these injectors. So when I do measure these, I just measure from point to end, but as long as I keep that measurement consistent on all of them, it gives me an idea of what the car's doing. I've seen the ground side driver fail, and of course the voltage just goes crazy in here. Usually that's an ECU issue. Obviously you got to check your pin fits and grounds and stuff, but if they all check out, I have seen these drivers fail, which is what I thought was wrong with this car, but it turned out it wasn't. So that's my spiel on direct injection, or at least on the Nissan side, peak and hold style. Current is about 8.5 amps. These are solenoid style. I do have a little post on my Instagram where I checked a piezo style direct injector on a Cummins diesel. Of course, they're running thousands and thousands and thousands of PSI. I did check voltage. Definitely got to use an attenuator. It's over 100 volts. And those run crazy amounts of amperage, and the waveform is pretty crazy. I haven't done a YouTube video on that yet, but there is a video on my Instagram where I just checked a known good and just threw it up there for common knowledge. So hope you guys enjoyed this video. As usual, if you have any questions, please let me know. Thank you guys. I got a lot of new subscribers. I appreciate that. The channel seems to be growing. Anybody down in Florida, you guys be safe. I think the hurricane is roaring through or coming through. It's actually headed my way here in Virginia, and we're kind of battening down the hatches. But get this video out before I lose power, lose internet, and all that good stuff. Have a good one. Thanks for tuning in.